Hi everyone, we're going to continue with some Chapter 2 homework problems, and this is number 11. A Cessna aircraft has a liftoff speed of 120 kilometers per hour. What minimum constant acceleration does the aircraft require if it is to be airborne after a takeoff run of 240 meters? So for part A, let's write down what we have. It has to have a takeoff run of 240 meters. So that's the minimum distance that it has on the runway that it has to be off the ground for. Now, it has a liftoff speed of 120 kilometers per hour. So if you're unfamiliar with aircraft start down at the end of the runway with a velocity of 0. They build up speed, and when they reach their takeoff speed, they then can lift off the ground. That's pretty ugly aircraft. Sorry about that. Now, we know that that's 240 meters. We know that the original velocity is 0 at the end of the runway, and we know the final velocity is 120 kilometers per hour. The problem is asking at what rate must that aircraft accelerate in order to achieve that takeoff speed. Now, if we look at this, XVO, VF, and A, what equation comes to mind? Well, to me, this is VF is VO plus AT. Oops, I said that wrong. How about VF squared is VO squared plus 2AX. There you go, much better, because these are the variables that are in this equation. Now we're solving for acceleration, so let's go ahead and do some algebra and solve for acceleration. I need to get rid of the VO, so I'm going to subtract VO squared from both sides. When I do something on one side of an equation, I've got to do it on the other. So this turns into VF squared minus VO squared is 2AX. Now, I still want to get A alone, so how do I get rid of 2 and X? To get rid of 2 and X, I'm going to divide this side by 2X and all of this by 2X. The 2 will cancel, the X will cancel. All of this is going to turn into acceleration is final velocity squared minus original velocity squared divided by 2X. Remember what I've said many times in the past, if we do algebra like this together and you are not algebra confident, it is not cheating to write down a rearrangement on your formula sheet. That's just considered smart. Okay. Now, before I can put the numbers into here, let's go back and see what I've got. I've got meters and I've got kilometers per hour. You cannot mix these two together. When in doubt in physics, we have to go back and we have to work with these MKS units, meters, kilograms, and seconds. So I am going to convert this 120 kilometers per hour into meters per second, because that way it'll be very, very convenient and we can use it forevermore in this problem. So I'm going to get rid of kilometers and go to meters on my orange sheet or my conversion sheet. I know there are 1,000 meters in 1 kilometer. Cancel kilometers. I'm left with meters. Keep those. I want to get rid of hours, so I put hours kitty corner from itself, and I want to keep seconds. We know there are 3,600 seconds in an hour, 60 seconds in a minute, and 60 minutes in an hour. Those two are going to cancel. Meters over seconds. Now I pick up my calculator after I have the entire thing written out. 120 times 1,000 divided by 3,600, and I ended up with 33.3, repeating, meters on the top, seconds are on the bottom, and that is my final velocity. Now that I have that in a convenient MKS unit, I can go back and use my equation. So let's do that. Final velocity here is 33.3 meters per second, whole thing squared, minus the original velocity, which is 0, divided by 2 times the displacement, 240 meters. Now, when I put all of this through my calculator, 33.3 squared ends up being, and I'm going to do an intermediary step here because people get lost right about here sometimes, meters squared per second squared, 2 times 240 is 480 meters. And you don't have to do this. You can do this all on your calculator, but frankly, this is where people get lost. So I'm going to take this, I'm going to divide. So I'm going to have 1108.89 divided by 480. And that gives me a rate of acceleration of 2.31 meters per second squared. Now, where does this come from? Well, this is going to come from meters squared per second squared divided by meters. So we're going to invert and multiply. Meters squared per second squared times 1 over meters. This meter cancels that. Meters per second squared. The algebra was done correctly. I do end up with acceleration units. Life is good. There is a part B to this problem, so let's go up and look at it. Part B says, how long does it take the aircraft to become airborne? How long does it take means we're looking for time. So let's go ahead, get in this last bit of room we have here, let's find time. This is going to be my part B. Time is going to be my question mark. And we have lots of choices for equations that we can use. Now that we have all of this lovely data, we have acceleration, we have final velocity, VO, X. I think I am going to use this equation because it's just such a little handy little poopsie. Final velocity is original velocity plus a t. Solving for time, I'm going to subtract VO from both sides. So VF minus VO equals AT. And then to get time alone, I'm going to divide both sides by acceleration. So time is going to be equivalent to final minus original divided by acceleration. That's my equation for time. So time will be my final velocity, which I found was 33.3 meters per second. 33.3 meters per second. Original velocity was 0 because it had 0 speed at the beginning of the runway. And my rate of acceleration that I just found up here, 2.31 meters per second squared. When I pop that into my calculator, that is going to be 33.3 divided by 2.31, and I end up with 14.4 seconds. Let's take a minute and see where those units came from. I have meters per second divided by meters per second squared, so we invert and multiply. Meters per second times second squared over meters. You're going to do a much prettier job than this. I'm running out of room. Second squared over seconds. This will cancel one of them. I'll end up with seconds. So that proves to me the algebra is right. Let's do one more of these, and that is, let's do number 12. Okay, problem number 12 says, a sports car is moving at a constant speed, travels 110 meters in 5 seconds. Then the brakes are applied and it comes to a stop in 4 seconds. Now, this is complicated because there are two things going on. You have some constant motion and you've got some deceleration. So this is a two-part problem. Part 1, you've got a constant speed. Part 2, you've got a deceleration or an accelerated motion. So we're going to divide this up into two parts. For part 1, let's write down what we've got. The sports car is moving at a constant speed and travels 110 meters in 5 seconds. So it's a displacement of 110 meters in a time of 5 seconds. Then the brakes are applied and it comes to a stop in 4 seconds. For part 2, it has a time of 4 seconds. What is the car's rate of deceleration during the braking portion of the trip? So during this portion of the trip, the braking portion, what is the rate of deceleration? Well, that's going to be my unknown. It brakes, so it has a final velocity of what? Yeah, final velocity of 0. We don't know how far it's traveled. Do we know its original velocity? We don't right now, but we can find it because its original velocity is going to be the speed it had during its constant velocity part of the problem. So let's go here and find its velocity for the constant part, and that's going to give me my original velocity for the second part. Now, when you have a constant speed or constant velocity, there's only one equation you can use, x over t. It's the only equation you can use for constant speed or constant velocity. So 110 meters, 5 seconds, 5 seconds. Pick up my calculator. What do I get? 110 divided by 5, 22 meters per second. That's my constant speed. That goes up here as my original velocity. I can now find my rate of acceleration. Now, if I've got VO, T, A, and VF, which equation am I going to use? That little guy that I like so much, VF equals VO plus AT. I'm going to solve for acceleration. We just did the algebra in the previous example. So final velocity minus original velocity divided by time. And you're going to find as we go on, I'm going to do more of this, assuming that you got the algebra in a previous problem, or I'm going to do it kind of fast. Final velocity here is, let me just move this correctly. Final velocity is 0. Original velocity is 22 meters per second. And time was, how many seconds was it in the second part? Oh my goodness, I'm flying all over the place. 4 seconds. 4 seconds. So the rate of acceleration through the second part is 22 divided by 4 is going to be 5.50 meters per second. It's a negative because it's slowing, so negative 5.5 meters per second squared. That is the answer to part A. Part B, what is the total distance covered during the entire trip? Okay, the entire distance covered during the entire trip. Well, in part 1, it was 110 meters. We have to find out what it is in part 2, and we have to add the two together. So distance total is going to be distance in part 1 plus distance in part 2. So how am I going to find distance in part 2? Well, I think I'm going to use this equation. I think I'm going to use displacement is VF plus VO divided by 2 times time. My final velocity was 0. My original velocity was 22 meters per second divided by 2. All of this happened in 4 seconds. So how much distance was covered in part 2 of the journey? Well, 22 divided by 2 is 11. 11 times 4 is 44 meters. Meters per second times seconds, that cancels the seconds, so 44 meters in part 2. So back up here, the distance covered in part 1 was 110 meters. The distance covered in part 2 was 44 meters. Add those together and I end up with 154 meters is the entire displacement for the entire journey. Part C, let's change ink color and let's go look at part C. Part C asks this question. What is the total time for the trip? What's the total time for the trip? Well, this looks pretty easy, and I just want to erase, make sure I'm not missing something. What's the total time for the trip? Oh gosh, this is really easy because of the fact that this portion of the trip took 4 seconds. This portion of the trip took 5 seconds. Part C is easy. Total time is 4 seconds plus 5 seconds. The total time is 9 seconds. Easy weasy. All right, that will do for this problem. I'll see you next time. Bye-bye.